Okay, 8.5, counting principles. And this picture of t-shirts and shorts and different combinations of t-shirts, shorts, and one pair of shoes gives you a hint about what is to come. All right, so let's look at this word problem. You're picking a breakfast, and it consists of a beverage, a protein option, and a carb option. And you were wondering, hey, how many different ways could I put a breakfast together, given that of these three choices that I have to make, I have different options for each one. So I put 3 lines, and when we're doing the method that we're going to use with this problem, which is the fundamental counting principle, we're just going to intuitively use lines to represent events. Like this line represents the first event, and you're like, what event are you talking about, Miss Overby? Well, the event of picking out a beverage, right? So my first event is I'm going to pick out a beverage. How many different ways could I do that? Well, there's 3 different types, right? Water, OJ, and coffee. So I'd put a 3 up here. My second event is going to be to pick a protein option, right? And I have how many different ways to pick a protein option? I have 4 different ways: egg, cheese stick, sausage, yogurt. And then the third event is going to be picking out my carb. Oh my goodness, I'm going to spell card, aren't I? Okay, I'm going to pick out my carb. I'm a little sick, so hopefully I can focus through this video. And I have 5 different carb options. And so if I'm going to use this method to solve this problem, I'm going to go ahead and say, well, if I have 3 choices for beverage, 4 for protein, 5 for carb, I am going to go ahead and multiply those because remember we talked about how a lot of times and means multiply. Usually it does mean add, I get that, but in this case and is going to mean multiply. I'm picking out a beverage and a protein and carbs, and so I'm going to go ahead and be multiplying that through. 3 times 4 times 5 is going to give me 60. There are 60 different ways I could pick out a breakfast given these options. Now, you could have done it a different way. You could have made a Venn diagram. You could have actually listed all 60 different ways. But the fastest way to find all the different amount of options that we have for a problem like this is to use what's called the fundamental counting principle. And so I'm going to go ahead and ask you to pause the video, read this, and understand that we actually use this. Right? So pause it, and I think that what I really want you to notice is that the definition is right up here, and then they talk about an example. All right, pause and read. All right, so when we're looking at this second problem, 16 students entered their beautiful mandalas in a contest. There are no ties, and how many ways can the top 3 prizes be awarded? And we can do the fundamental counting principle here, right? We can decide that there are 3 events. The first event is picking the first prize, right? The second event is second prize, and the third event is third prize. And we say, okay, well, and how many ways can we choose the most beautiful mandala? Well, there's 16 to choose from. So when we're looking at all 16 to choose first place, well, we have 16 ways to choose, right? There's 16 options in front of us to choose from. But then we picked one, right? One of them got first place prize. So now we're only looking at 15. So to choose second place, we're only looking at 15 mandalas in front of us for second place. So then we chose one for second place. Well, now there's only 14 left to look at and choose from. And so there's 14 ways to choose third place. So if we want to know how many ways are there to choose all 3 prizes, we would multiply because there's 16 ways to choose first prize and 15 ways to choose second prize and 14 ways to choose third prize. I know it's going to be a little adjustment to consider and as multiplication, but when we're talking about counting principles, that's and probability, and is going to mean multiply. And so hopefully I picked up a calculator before I did this. Yes, I did, and I multiplied them. There are 3,360 ways to award first, second, and third place. But hold everything. there's actually a different method that also works to solve this problem. And I want you to understand both ways, so then you have the choice of which method you would use when you see this. So remember how we did a binomial expansion and we saw NCR, and I kind of gave you a hint, hey, we use this in probability. Well, there's also something called NPR, and NPR is a little different than NCR, and I'll talk about both of them in this lesson. So when we see the P, this P stands for a permutation. And a permutation is just another way of saying choosing things when order matters. So go ahead and write that down. When we use NPR, we're using that, and the P stands for permutation, when we're choosing from things and order matters. Now, if you want a fun video on what NPR and NCR are, you can go ahead and look back on the blog, and I did a creative video for counting principles and a creative video for probability. Some people love them, they're fun. Some people are like, oh my gosh, what is she doing? So you can absolutely check those out. But I talk in those videos about getting a perm. And if you've ever had a perm before, like I did back in the 80s, a perm has a certain order to it. And so if you went into the beauty salon and the person doing your hair did the perm in the wrong order, your perm's not going to turn out. So when you're getting a perm, order matters. Therefore, when you're doing a problem where order matters, you want to be doing the permutation, which is the NPR. All right, if you want more of that, check out the other video. So what do you mean order matters, Miss Overby? What are you talking about? Well, imagine that you had just done a mandala and you were in this contest. Would it matter to you whether you got first, second, or third? And if you can say yes, now some of you are like, no, I don't care, but most of us care. Order does matter. We want to be picked for the first prize, especially if first prize comes with $1,000, prize money. And so when we can say yes, order matters, we're going to use NPR. All right, now, what does that mean? So what that means is that the N for NPR is going to stand for how many things are we choosing from. And in this case, we have 16 mandalas to choose from. And the R stands for how many things are we choosing? Well, we're choosing first, second, and third place. So we're choosing 3 prizes, right? First, second, third place. So what we're going to do is pick up the yellow calculators and we'll put that 16 in, and then we'll hit prob, right? We'll hit that button prob, and then we'll scroll down and hit the NPR, right? Hit enter. I'm sorry, yes, hit enter after the NPR. So we'll hit enter. And then we're going to go ahead and push the 3, and then we'll hit enter again, and you will end up with the same answer, the 3360. And I know what you're saying. You're like, well, Miss Overby, I kind of like just using the lines better because it's more intuitive. And that's true. But sometimes it's going to be way better to pick NPR. Like, let's say in this problem there were, 30 mandalas and we were giving out 15 prizes. Do we really want to make 15 lines? That's when the NPR is going to be a lot easier. So let's look at this next one. Target had 100 pencils with different positive sayings on each of them, and you decide to buy 3. How many different combinations of 3 pencils are possible? So here's the thing about this one. First of all, I'm gonna go ahead and set up my lines, but I'm gonna run into some difficulty, and this is why. So Target has 100 pencils, but we're picking 3, okay? And so we start out with, we look at the 100 pencils and we pick out our 100, out of our first one we're gonna pick up, we have 100 to choose from, and then we have 99, and then we have 98 to choose from. But here's the problem. If we multiply these 100 times 99 times 98 in our calculator, we are not going to get the right answer. And the reason why is that we are just walking out with 3 pencils from Target. We didn't say we're choosing 3 pencils. One of them is going to go behind my right ear. One of them is going to go in my front left pocket. And one of them I'm going to carry in my left hand. You know, that would be different because order would matter. There'd be 1 pencil for behind your ear, 1 pencil in your pocket, and 1 pencil in your hand. So even if you had 3 pencils, there are 3 options for those 3 pencils. But it doesn't say any of that. And so basically, if we were going to do the counting principle, we'd have to correct the counting principle by dividing by 3 times 2 times 1. So all of a sudden, I get it. You're looking at it like, Ms. Overby, I don't want to do the fundamental counting principle for this one. I don't either. So now let's look at something called NCR. So the NCR is the same thing that we did with NPR, except for the C stands for combinations, not permutations. Combinations. And we want to use combinations when we're choosing from a group and we're choosing a certain amount from that group, but order doesn't matter. There's no prizes, there's no becoming president or vice president, just order doesn't matter. We're going to use NCR. And so what we're going to do is we're going to say how many things are we choosing from. That's 100. We're going to put that in our calculator. That's our N. Then, of course, we know that we've got to find the NCR button and push that, hit enter. And then how many are we choosing from these 100 pencils? We're choosing 3. We put that in, we hit enter, and what do we get? We get 161,700,000 ways to do this. So we can already see in this problem that if we can use NCR, it's a better way to go because counting principle doesn't always work. It only works actually when order matters. If order doesn't matter, we've got to do the division. And if that division didn't make sense to you, don't worry about it. Just use combinations. All right, so you've seen the 3 counting principles that we're going to use in class. And the first one was the fundamental counting principle. So we're going to go ahead and write it down again. Fundamental counting principle. And that one is nice to use when we have options, like the breakfast options. And when we decide to use it, we make lines for each option. And sometimes we call those options events. Okay, for each option or each event. And then we write the number of choices for each option or event. If I'm writing it down, please write it down. Your notes, as we've learned, really do help you to prepare for the test, and make sure your notes are complete. So it's pretty obvious when we use the fundamental counting principle. We use it when we can't use NCR or NPR. And once you do more homework, once you do homework and you practice, you'll know exactly when to use fundamental counting principle. And so there's a second one, and that was we used NPR. And these are permutations. That's what the P stands for, permutations. And we use when order matters. Now we're going to spend some marker board time going through different scenarios so that you can get better at deciding if order matters or not. And then lastly, we have the NCR, and that we call those combinations. They're also when we are choosing, just like with NPR, we're choosing from a group. So we use this when we're choosing from a group. And order does not matter. Once again, we're going to use a marker board and have some fun with practicing when to use which one. But before we do that, there's one more thing we need to learn, and that is what happens when somebody asks us, in how many distinguishable ways can the letters in the word apple be written? Now, it's not asking, I remember back in elementary school, the game, like maybe it'd be a longer word than apple, like calculus or something. And the game would be, hey, see how many words you can write from this big word. And whoever writes the most words wins the prize. I don't know if you play games like that, but I do remember playing games like that. That's not this game. We're not asking for how many different words you can get out. We're asking like this. Like, look, if I wrote apple like this, that's one way. I could write apple like this. I could just switch out the A and the P. That's a second way. It's just asking how many different ways can you switch the letters around so it looks different. That's what distinguishable means, so it looks different. So let's try this. We've got 1, 2, 3, 4, 5. This does not seem like an NPR or NCR because we're not choosing anything. It's not saying, first, second, or third, or you're buying something, or, so we're not going to use NCR or NPR, so we're going to use our little fundamental counting principle, and we're going to write out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to say, how many ways can I choose the first letter? Well, there are 5 letters, so I can say I've got 5 ways to choose the first letter. And so once I choose the first letter, right, that's gone. I only have 4 ways to choose the second letter, 3 ways, 2 ways, and 1 way. So I know some of you are going, wait a second, Miss Overby, this isn't really going to work. So if you're not thinking that, pause the video and see if you can think why we're not done yet. Okay, so hopefully you've had some time to think about it, and I want to ask you something. If I told you that these 2 ways of writing apple are 2 totally different ways, would you say, but Miss Overby, they're not distinguishable? And I'm like, yeah, but they're different. And so this is what I may be talking about. This P, I might say that's my first P and that's my second P. And this second time I wrote it, I switched the P's. But you can't tell, can you? And so technically what we've done, not technically, but what we've really done is if we let the answer as 5 times 4 times 3 times 2 times 1, we're saying that when you switch the P's, that's a different choice, and it's not because of the word distinguishable. So what we have to do is we have to undo. We've actually doubled the amount of choices we really have. And so what we have to do is we have to divide. When we want to make a value smaller because we've counted something twice, we're going to divide by 2, right? And so basically what we're going to do is we're going to say, well, we had 2 letters, P and P, where we had, when we first wrote a P down, we had 2 to choose from, and then we had 1 to choose from. You don't have to do the 2 times 1. You can just divide by 2 if that makes sense to you. But you're going to go ahead and put that in your calculator, which I did not do. So let's see if I can do that real quickly. I don't have a calculator nearby, but the 2 and the 1 will cancel out, and so we'll have 60, right? There's 60 ways to do this. All right, let's try banana. So when we're going to do banana, let's go ahead and say, well, there's 1, 2, 3, 4, 5, 6. So I'm going to do the fundamental counting principle on the top. So I'll write my 6 lines, 1, 2, 3, 4, 5, 6. And then I know I'm going to have to divide by something. But let's go ahead, and I know I have 6 times 5 times 4 times 3 times 2 times 1. And then, but I'm like, wait a minute. I've got 3 A's. All right, so I have to be really careful. And if I keep writing there, if I leave this as my answer, I'm actually counting my A's 3 times 2 times 1 time. Okay, and I'll tell you, I have 3 A's. Each time I write an A, I have 3 to choose from. I have then 2 to choose from the second time and 1 to choose from. So I've actually counted a word or a fake word 6 times that actually is not distinguishable from the others. So that's why I'm going to have to divide by 6. And then I look at, let's switch up my color. I look at the ends. I have 2 ends, so I'm going to have to divide by 2 times 1. So I don't have a calculator with me. Let's go ahead and put this all together. I'm going to start canceling out some things. My 3 cancels out. That cancels out. You can pick up your calculator, actually. We'll have what? 30 times 2, which is 60. Gosh, it's funny that it ended up being the same answer. Now, if you look in your book, you'll see that they don't use the counting principle. They use factorials. So if you wanted to use factorials, you could do the same thing. See how we did 6 times 5 times 4 times 3 times 2 times 1? You could write 6 factorial. And then instead of 3 times 2 times 1, you could write 3 factorial. And then instead of 2 times 1, you could write 2 factorial. I prefer using the counting principle because it just seems to make more sense. But if you like this, let's go ahead and use that as a second option. You can choose whichever one you want. You always, in these distinguishable permutations, you always count your letters that you're given, 1, 2, 3, 4, 5, 6. So we'd start with the 6 factorial, and then you'd count how many of the same letter you have. Like for instance, we had 3 A's, so that's where the 3 factorial came from, and we had 2 N's, so that's where the 2 factorial came from. So if you want to do it that way, you are welcome to do it that way. All right, so go ahead right now, pause the video if you're watching this at home, and gosh darn it, you don't have marker boards at home, do you? If you're watching this in class, go grab a marker board, and if you're watching it at home, just grab a scratch sheet of paper because I want you to actually commit to an answer before you hear me say the answer. All right, pause it, and I'll see you in a second. All right, we're going to play the game permutations or combinations. So here we go. What if you had a problem where you had to figure out how many ways a running race could end? Think about it. Commit to an answer. And what do you think? That's right, it's permutations. Okay. If I'm running a race, I want to get first or second or third. Order matters. There's a difference between getting first and last. Order matters. So this is a permutation. You could even just write NPR. All right, what about if you're looking at a problem that involves picking 3 friends to travel with? Pause it, commit to an answer. All right, did you guys get, NCR? Yeah, does order matter here? You're just picking 3 friends to travel with. Those 3 friends are coming with you. Now, it's different if you told them something like, well, one friend gets to sit in first class, and one friend gets to sit in, coach, and the other friend has to sit way back in the back of the airplane where the motor is. I don't know. That would be different, right? But here, just 3 friends are traveling. Their order doesn't matter. They're just all traveling. So that's an NCR. All right. How about being picked for one of 4 roles in a movie? Pause it, commit to an answer. All right. Do you care which role you get? I know I do. I'm not an actress, but kind of secretly wish that I was. So I would want the role where you got to be dramatic and cry and scream. I don't know, that sounds fun. Order matters. You would maybe you don't want the role where you have to be mean. I wouldn't want that role either. So we are definitely committing to NPR. 4 roles in a movie, order matters which one you get. Okay, ready? Pause and commit. 10 students lining up to leave. The key word here is lining up. They're lining up. They're not just congregating by the top of the stairs. For some reason, we're lining up this time. Does order matter? You better believe it. Most of you would want to be that very first person, or at least be in the front of the line, because you want to get out of here faster. So order matters. It's a different experience if you're at the end of the line than at the beginning of the line. So once again, try to put yourself into these scenarios and ask yourself, do I care? All right, if you're apathetic about things or just super laid back, maybe ask, would someone else care? Okay. What about picking good, better, and best out of 10 drawings? Pause, commit to something on your marker board, and come back. You betcha. That is an NPR. I want the best, right? I want to be picked best, doesn't everybody? All right, how about picking 3 books for a weekend of reading? Commit. That's right. Order doesn't matter. Just 3 books for a weekend. Now compare this with the next one. Wonder if you were picking 3 books. One for Friday, one for Saturday, and one for Sunday. Now you have to imagine that you're a book. All right, commit to your answer. And that's right. Order does matter. It's a different experience for you and the book, if the book can experience. If you picked a scary one Friday night, a sad one Saturday, and a funny comic comedian type one on Sunday, right? Different experiences, so order does matter. I'm hoping that this is helping you see the difference between NCR and NPR, because once you read these problems and you can commit to either NCR or NPR, then it's just picking up the calculator and plugging the numbers in. All right, 5 friends sitting down to eat at a table for 5. All right, that's right. It is, order does matter. I don't want to sit by the table where the baby's crying at the table right behind it, or maybe I want to sit by the window. Order matters when you're sitting down to eat at a table for 5. Okay? If you imagine a table for 5, well, I don't know what that would look like. Maybe 2 seats here, 1 seat here, 1 seat here, 1 seat here. Maybe this is on a bench. Who wants to sit on the bench? Order matters here. All right. What about 5 friends sitting down to eat at a table for 5 with 1 friend insisting on sitting in the chair by the window? All right, this is a tricky one. And I put this in on purpose because we see that 5 friends are sitting down to eat at a table for 5, but that 1 friend is really messing this up. If that 1 friend wasn't insisting on sitting by in the chair by the window, we would say this is a straight up NPR. But this is much better for fundamental counting principle 1. I would go ahead, I've got 5 friends, 1, 2, 3, 4, 5. And the only thing I know for sure is there's a seat by the window and 1 friend insists on sitting in that chair. We all have a friend like that, right? There's no budging them. There's no compromise. Darn it, they're sitting in that chair by the window. 1 person's there. All right, so if 1 person already sat down, and the rest of the seats are open, and we were trying to figure out and how many different ways could we sit everybody, we would say, well, there's 4 people left, so 4 times 3 times 2 times 1. Okay, or you could just do well, I think this is the best way to do it because I'm thinking about problems down the road where when it's a combination, it's like, it's kind of NPR, but we got this little problem here. Then you would want to use the counting principle there. All right, hope you had fun. Oh, we're not done. All right, ways to pick 2 people out of 20 to clean up after the picnic. All right, commit to an answer. NCR. Those 2 people are not given specific jobs. The order doesn't matter when you're picking the 2 people out of the 20. Yes, I agree. None of us wants to be those 2 people. But if the question asked, how many different ways can we pick 2 people out of 20 to clean up after the picnic? We are going to use NCR because order doesn't matter. Now compare that with this next one. We're looking for how many ways we could pick 2 people out of 20 to either pick up trash or help load the buses. Commit. And yes, you're right. It is an NPR. Order does matter. So, right? Because I don't know about you, but I'd rather help load the buses than pick up the trash. So when you can put yourself in the problem and say, does it matter which one I'm picked for? Then order matters, and you would pick the NPR. And you pick up your calculator and you put 20 NPR 2 and hit enter. All right, hopefully that helped you. I've got one more little thing to do, and it's going to be in that little, or the rectangle at the very, very bottom. You're going to see in the beginning of your homework problems about a random number generator. So please stop and write random number generator, because when you start your homework with these, you're going to be like, this is nothing like she did in the video. And you're right, so that's why I added this. So here's the deal. You could see, let me drop my marker. So you could see this problem, and it says, in how many ways can a random number generator pick an even integer from 1 through 20? So go ahead and pause the video and write that down. And you're back. So this is kind of just a logical type of question. We're just going to say, well, How many even integers are there from 1 through 20? And if you have to count 2, 4, 6, 8, 10, and realize that there's 5 even integers in the first 10, right? And then 12, 14, 16, 18, 20, there's 5 even integers in the second 10. You could do it that way, or you could just divide 20 by 2, and you know that there are 10 integers, 10 even integers from 1 through 20. How many ways can a random number generator pick an even integer? So it's just picking it's one pick. There are 10 even integers for it to pick from, so your answer would be 10. I know, that's kind of like a, what? But I wanted to include this in our notes because you are going to see it in the homework. And there's a second type of random number generator that you're going to see in your homework. So go ahead and pause and write this down. Okay, and how many ways can a random number generator pick 2 integers from 1 through 10 whose sum is 12? This, once again, is just logical. We're going to go ahead and write down that we're picking, there are 2 picks, but it's not even a fundamental counting principle. It's really just logic. So I think about the number 1. 1 plus, oh no, I can't use 1, can I? 1 plus nothing from 1 to 10 is ever going to give me a 12. I can use a 2. 2 plus 10 is going to give me 12, right? I can use a 3, 3 plus 9, I can use a 4, 4 plus 8, right? I use a 5, 5 plus 7, I can use a 6. And since the number generator, when it's picking 2, the first event, right, is picking the first number. So event 1 would be pick first number. Event 2 would be pick second number. So do you think it would make sense that I could keep going? I'm going to switch colors, and I could count. See how I did 2, 10? I could do 10, 2. Well, let me write it next to it. That probably didn't make sense to write it right there. But that would also be another way, right? 2, 10 is different than the number generator doing a 10 first and then a 2 second. Do you agree? And then same thing with 3, 9. 9, picking a 9 first and a 3 second is different than picking a 3 first and a 9 second. So I'm going to count these as well. Now, here's a tough one. A lot of people mindlessly write 6, 6. But you know what? I don't know about you, but if I was sitting there watching the number generator spit out the numbers, and the first number that came out was a 6, and the second number came out was a 6, and then that happened again, the first number came out was a 6, and the second number came out was a 6, I'm like, yeah, that's the same thing. So I'm not going to write it again. Do you see how that's different? We're not going to write 6, 6 again, because you can see how it's different if we were watching the number generator and it spit out a 5 first, then a 7, and then we were watching it spit out a 7. I don't know if it's spitting out, whatever, and then a 5 second. That's totally different. So altogether we have 1, 2, 3, 4, 5, 6, 7, 8, 9 ways, right? There's 9 ways for a number generator to pick 2 integers from 1 through 10 whose sum is 12. So once again, I wanted to end with those because those are kind of different. All right, the real learning really does come with tackling the problems and deciding which method to use. So I'm hoping that you may take advantage of your homework time, whether you're at school, and I'm teaching it if you're at school, but if you're at home, really dive into these. Of course, check your answers. They're in the back of the book, the odd problems. Thanks for joining me, and really put your all into trying to figure out these problems. Thanks. Bye.